guys, welcome back to the channel. Jag here, and in today's class we're going to continue with our Chemistry 11 content. Let's move on to the next topic. So this topic is basically on percentage composition. So with that, we're going to try a couple of examples from the textbook. So let's get started. Okay, so what I'm going to do is basically read out the question from the textbook that we're going to try as an example. Okay, so a compound with a mass of 48.72 grams. Okay, so I'm just going to put that down here, 48.72 grams, okay, is found to contain 32.69 grams of zinc. Okay, so 32.69 grams, this is for zinc, and it contains 16.02 grams of sulfur. And this is basically the exact mass, okay, for each of the compounds that's given. Make sure you have your calculator handy. And let's get started. It says, what is the percentage composition of the compound, okay? So when you're doing the percentage composition of the compound, what you want to do is the mass is given here. So there's just a little bit of simple math. So let's try the percentage of zinc. Okay, so all I'm doing is I'm going to take the mass of zinc and divide it by the total mass of the compound. Okay, so the mass of zinc is 32.69 over the total mass of the compound, 48.72 grams. All right, times 100%, okay? And you notice I'm not really putting the units like grams here. I don't need to write that in the actual formula, okay? So all we're doing is just dividing these two numbers together. Okay, put the equal sign in between and then you times it by 100. Okay, so I'm going to put 67.1%. Okay, so usually for the percentage composition, I want to make sure that I'm rounding it to one decimal place. Okay, so let's try. Okay, let's try the percentage of sulfur. Now some teachers might want you to write out a formula. That is up to your teacher, and some teachers are picky again, so make sure you're writing the formula before you plug in the actual values, okay? Because I know this is a little bit of simple math. So let's take the mass of sulfur, so 16.02 grams, divided by the total mass, which is 48.72, and then you're going to just multiply this by 100%. Okay? And what you're getting is, we're going to just put it into our calculator because there's a bunch of decimals here. And then times 100%, and we're getting 32.9% of sulfur. Okay? And what is a way that I can check to make sure my answer is correct? Okay, what I'm going to do here is I'm just going to add the percentages together. Make sure you're watching the rounding, okay? So I can't round the percentage of zinc to one decimal and then round the percentage of sulfur to a whole number, because that's not going to add up to 100%, okay? So for all the questions, you should just be rounding it to one decimal place, and that makes it very accurate, all right? Are there any questions so far? All right, so that looks good. So we're going to move on, okay, in our textbook to the next example. So I'm going to take this off. Okay, and this next example is slightly different, okay, but we're still calculating the percentage composition, okay, of this compound. Okay, so I'm going to, again, read the question out, and I'm going to write down the most important information that's given here, which is not much, okay, and you'll see just why in a second. Okay, so aldehyde, okay, this is a formula for it, so C9H8NO. Okay, so aldehyde is responsible for the characteristic odor of cinnamon. Okay, so maybe that's not something you knew. This is a specific compound that causes that smell. And remember, cinnamon has that very distinct type of smell, right? So determine the percentage composition of aldehyde by calculating the mass percent of carbon, hydrogen, and oxygen. Okay, and this is the only information that is given to me. All right. And when you're looking for the percentage composition here, from the actual formula of the compound, all I'm doing here is finding the total molar mass, all right? So let's start off with that. So we're going to do the molar mass of the compound, so C9H8NO. And again, remember, if you don't kind of recall how to do the molar mass, you can check out one of my previous videos, and it was just on calculating the molar mass of various compounds. All right, and that would be a good review for you. So what we're going to do is the molar mass of this compound. Okay, again, check your periodic table here. Okay, and we're looking at the mass, okay, of each of the elements and count the number of atoms. Okay, so the mass for carbon is 12. I'm going to times it by 9 because there are 9 atoms of carbon here. Plus hydrogen, let's do hydrogen first. 1 times 8, okay? And if you're looking in the periodic table for oxygen, it is 16. So I'm going to put plus 16. There's only 1 atom of oxygen, so I don't need to put times 1 there, okay? So we're going to multiply all of this together, and I'm going to add it together in one step, okay? So we're getting 132 grams per mole. And again, make sure you are putting grams per mole. Teachers are taking off marks all the time, okay? So I have the total molar mass here, okay, of my compound. So first we're going to start off with the percentage of carbon. I'll put percent carbon, okay? And so on the top should be basically the mass of carbon. So again, we'll just put 12 times 9 over the total molar mass, which is 132 times 100%, okay? And again, if I want, I could just do this in one step, okay? So it's going to be 108 divided by 132 times 100%, okay? And again, I'm going to round it to 1 decimal place. So we're getting 81.8%, okay? This is the percentage of carbon. Then we're going to do the percentage of hydrogen, which is 1 times 8, okay? And again, I'm just rounding the mass that you have in the periodic table. You can just round that to the nearest whole number, okay? Over 132, and then times 100%, okay? So this is just going to be 8 divided by 132. And then you're going to times it, so I have 6.1%. Okay, usually the percentage for hydrogen in any compound is going to be quite low. And that's because the mass of one hydrogen atom is actually only 1.01 grams per mole. Okay? And lastly, let's do the percentage of oxygen. It's just going to be 16 divided by 132. Okay, and we're going to times it by 100%. And we are getting 12.1%. Okay? And one more time, what we're going to do is just add all these percentages together. And I'm getting exactly 100%. And that is actually a really good check, okay, to make sure that your answer is correct, okay? Teachers do take off marks for basically the rounding, so make sure you're rounding all the percentages to 1 decimal so it adds up together, all right? So that brings this video to an end, and today we covered Chemistry 11, the very important concept on percentage composition. If you learned something, make sure you are clicking on the like button below and subscribe to my channel. And I'm gonna see everyone in the next video. Thanks, bye.